Hello everyone. I welcome you all to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best college in entire India. It offers a variety of courses from BTech, BBA, BCA, and also upcoming with LLB, MBA, and architecture. This is the best career choice that you can make for yourself or your child's future. It provides 100% placement and n number of opportunities for your growth. The subject that we shall be discussing over here is Principles of Software Engineering. Code is CSE 302F. This is a CSE 6 semester subject. The syllabus is in accordance to MD University Rohtak. This is the third lecture from unit number 2. The topic covered here shall be Specification Principles, Representations, the Software Requirement Specification or the SRS. I, Shalini from CSE department shall take you forward. Specification Principles. Specifications may be viewed as a representation process. Requirements are represented in a manner that ultimately leads to successful software implementation. A number of specification principles adapted from the work of Balzer and Goodman can be proposed. Specification principles are already defined, and they should be defined in a principle in a way such that the requirement should lead you to automatically successfully complete the software. So the specifications has to be very well defined. So here we discuss Balzer and Goodman's principles that they proposed. First is separate functionality from implementation. See, the functionality has to be defined separately from implementation. So before implementing anything, the functionality has to be priorly defined. Develop point number 2. Develop a model of the desired behavior of a system that encompasses data and the functional response of a system to various stimuli from the environment. This is very important. See, here we need to develop a model according to our need of the system, that is encompassing, or I would say that take care of all the data and the functional response of a system, right? That how will the system is going to response according to the stimulus from the environment, or I could say that anything coming from the outside, that how will the system actually give you the output with respect to the corresponding input, right? So you need to develop a model according to your desired result that you want. Point number 3. Establish the context in which software operates by specifying the manner in which other system components interact with software. So there needs to be a proper context in the way that how the various components of the system shall be interacting, right? Because you need to define it, there need to be specific principles for it, like that how one component will talk to the other component. Point number 4. Define the environment in which the system operates and indicate how a highly intertwined collection of agents react to stimuli in the environment produced by those agents. See, defining the environment is very very important. Like, my software will be suitable for which environment, right? See, if I have developed a software that is corresponding to a washing machine program, so I cannot go out and implement it into a microwave oven, right? So defining the environment is very important as to what exactly will be the environment in which the software will be operating, right? And how highly intertwined collections of agents react to stimuli in the environment, and how those will be reacting to the various stimulus the environment is providing them, right? See, if it is a weather forecasting system that is being developed, so it has to respond it has to provide you stimulus. It will provide you result based on the input that it receives, right? So first the environment and how it reacts to the environment. Both are important. Point number 4, create a cognitive model rather than a design or implementation model. The cognitive model describes a system as perceived by its user community. See, up till now, whatever that we discussed all the STLC models, the prototyping methods, also all methods, all models, whatever we learned. We started with requirement, then we went to designing, then implementation, testing, and etc. etc. But before designing or putting anything into implementation, your design has to be a cognitive model, because in your mind you need to have this model clear cut defined as to what exactly you want. Only if the cognitive model is clear, then you will be able to design the design and the implementation model, right? Because see, if anything, design, you can proceed implement the product according to the design, but if the design is not correct or up to the mark, then you have to have a mental thought into your mind that this is what exactly I wanted my product to look like, right? So you can then, according to your cognitive model or your conceptual design, you can actually change your design and thus your implementation, and then you can better your software, right? So this is very very important. So before writing down anything, first it has to be in your mind, it has to be in your consign. That's why creating the cognitive model is very important. Point number 6, recognize that the specification must be tolerant of incompleteness and augmentable. A specification is always a model, an abstraction of some real or envisioned situation that is normally quite complex. Hence, it will be incomplete and will exist at many levels of detail. So, we first need to recognize that these specifications must be tolerant to incompleteness, right? See, if there are any kind of specifications that you define, and all this is being done by the software engineer, which is in the end is actually a human being, and human beings have this very 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 adapt on inherent a quality that they make mistakes. So your system has to tolerate any incompleteness that even you forgot to enter, or even if you forgot to define, then it need to have patience, it need to have tolerance for it, right? So it has to be tolerant of incompleteness, and it can be augmentable. You can always increase it and augment it, right? Point number 7, establish the content and structure of a specification in a way that will enable it to be amenable to change, right? So anything that you defined or anything, it has to be very very amenable, like to changing it, to change the content or to change the structure. So both of them has to be very very amenable, very very peaceful. It has to be, it should not disturb the entire working model or the entire specifications. So the specifications had to be written in a way that even if you forget something, or even if you try to amend something to it, you want to change something, it does not create a lot of problem to you. This list of basic specification principle provides a basics of representing software requirements. However, principle must be translated into realization. Representation. We have seen that software requirements may be specified in a variety of ways. Right? See, there are many, many ways to represent how you represent your environments, right? So, however, if requirements are committed to paper or an electronic presentation, right? Medium, a simple set of guidelines is well worth following. See, whatever you're writing your requirements, whether you're writing it on a paper or you're writing it on a common platform where others can read it, or say a common a word file that is shareable, or a common cloud, or you're writing anything on your drive, or you're writing anything on a shared resource, these points you should always keep in mind. And what are these guidelines? The first one is representation format and content should be relevant to the problem, right? So whatever the thing that you are representing, whatever the format you are representing it, whatever the content is there, it should always be relevant to the problem, right? So anything that you are You're representing your format, your content, your structure, your architecture. It need always be relevant to the problem. Information contained within the specification should be nested, which is very correct. Like, so your information, it always has to be inculcated into the specification. Your specification should always give you information that is contained in the system, or that is the system is designed for. So it should always come out, like the system specification should be such that the crisp or the information, or that the thing that it want to convey, it is clearly showing. Point number 3: diagram and other notational forms should be restricted in number and consistent in use. Right, so there should not be n number of diagrams. See, if you do anything into excess, even if it is diagram, or even if it is some notations or short form you're using, so that should not be, because it has to be restricted. It should not go on and on and on, that you need to keep on kind of taking the entire thing by diagram, because you need to somewhere deep down explain those diagrams also, right? So it should have this, you should have this restriction into your mind. Next is, representation should be revisable. So anything that you represent, it should be revisable, like you should be able to revise them again. However, software engineers appear to have individual preferences for specific symbolics and diagrammatic forms, which is very correct. See, every person works according to his mind. So every engineer which is working, it has a kind of a, he has an individual preferences. Some, suppose for example, some people have a habit of writing comment into two kind of a backslashes that you write, and the other writes one backslash and that exclamation mark. So it is very kind of individual choice as to what exactly symbols he like, or what exactly diagrams he would like to represent it. And so this is always the kind of thing that creates confusions. So familiarity often lies at the root of a person's preference. Whatever the person prefers and what is appear familiar to him. But other more tangible factors such as spatial arrangement, easily recognizable pageant, and degree of formality often dictated individual choice. Right? See, always a person is always, a person, we are always biased according to our choices and towards our choices, which is very basic characteristics of us, right? So similarly, the software engineers are also some basic preferences, but all these are more tangible. Then some spatial arrangement, and then it has very, like, easily recognizable patterns that it has, and degree of formality, like, see, if it is formal parameters and if are known to others also. So this is a quite an advantageous things. So simple patterns, simple arrangement, simple structures that are very easy. Actually, they should be preferred over to rather than individual choices, right? Software requirement specifications, or SRS. A software requirement specification is a document that captures complete description about how the system is expected to perform. Right. See, we from whenever we started doing is SDLC models or anything that we started it, we actually kind of, we were discussing that the requirement is very important. Retelling requirement is very important. Requirement has to be correct. Requirement has to be specific. We developed a prototype to actually refine our requirements. So everything, the requirement has to be occupies a base. So once this requirement becomes, actually you actually get a clear conscience of it. So the output of a requirement phase or requirement analysis phase is actually at an SRS, that is to be signed off at that point by both the customer as well as the agent. So this SRS was the one of the most important um, documents into the entire kind of the process of development of the software, right? Why? Because this is the one that will actually make both, will hold actually the user, the customer also, and the agent also is both accountable, right? Because this is the one thing that the two of you agreed upon, that the customer said that, okay, I want this and this is final, and then the person making this, he said that, okay, The agent said that okay, you want this and I will deliver this in this amount of budget in this amount of time, right? So SRS, the software requirement specifications, it is important because it will become the basis of again your any kind of a contract that actually goes inside being signed out. So your SRS will call clearly and very precisely or concisely should define your software requirements, right? So it is usually signed off at the end of requirement engineering, which is what we discussed in here. So what is the quality of SRS? It has to be correct, right? Unambiguous. There should not be any confusion or ambiguity into this requirements. The requirement has to be complete. It has to be consistent, ranked for importance and for stability also, right? So you should rank it. So this is my highest priority, and this comes at second number, and this comes in ranking number, so the third number. So this all these should be defined. It should be verifiable. See, requirement should always be verifiable. You'll be able to verify whatever that you have, you actually want to get it done. It should be modifiable and it should be traceable, right? So you should be able to modify it, verify it, and trace your requirements. What are the type of requirement in here? That is the diagrams. We can see that SRS captures all the diagrams. And what are the requirements? Functional, performance, interface, maintainability, reliability, safety, quality, operational, resource. So all kind of are being taken care of by this SRS. All the 9 requirements is the SRS will take care of each and every one. So what are the characteristics of a good SRS? It should be modifiable, like the qualities that we discussed. So similar are the characteristics of quality. You should not get confused. So modifiable, correctness, completeness, consistency, unambiguous, ranking for importance, verifiability, testability, traceability, design independence, understandable by the customer, and right level of abstraction, right? So all these are forms the good qualities or are said to be the good characteristics of an SRS. Next we come to important questions. The first is, what is specification principles? What is an SRS? What are the qualities of SRS? And last, what are the characteristics of good SRS? Software requirement specification, I again repeat, is a very important topic. So you should be able to define what exactly is SRS, what are its characteristics, qualities, what are the requirements that is look forward to. You should able to tell it. That's all for today. Thank you.